What I'm going to do is quickly graph in standard form. At this point, everyone should be familiar with standard form. So I'll quickly graph the first equation in standard form. We'll talk about our shaded region, and we'll talk about the answer, which looks a little bit different than when you have bounded regions. So you do have to pay attention to how to find your min or max value when you are doing these. We're going to go right through these like we did the last time. I'll label them, or I will number them so we can reference back. But the first inequality is x plus 2y is greater than or equal to 8. When we graph in standard form or in any form, you want to imagine that you are graphing the same inequality, but write it as an equation. So I'm changing my inequality symbol right here to an equal sign as far as how I want to graph. Graphing in standard form requires you to find your intercepts. To find the x-intercept, you set y equal to 0. When you do that, you're left over with x equals 8. So graphing this would give us an x-intercept at 8, 0. To find the y-intercept, you substitute 0 in for x. We have 2y equals 8. Y would be equal to 4. Therefore, your y-intercept when graphing is at 0, 4. We come down to the graph and plot both of these intercepts. On the x-axis, we plot a point at 8. On the y-axis, we plot a point at 4. You have to shade one side of the line, and the shaded side of the line would be whether it includes or doesn't include the point. So if I test 0, 0 into my original equation, actually into the original inequality, I substitute 0, 0 into x plus 2y is greater than or equal to 8. That would tell me 0 is greater than 8, which is false. So you would shade away from 0, 0, or the opposite side of the line. So you would be shading above the line. The next line that we're graphing is x is greater than or equal to 2, which when we graph as an equation is at x equals 2. The line x equals 2 is located here. It is a vertical line. Anytime you have x equals and then a number, as far as what you're graphing or as far as the equation goes, that's always going to be a vertical line. You can also think to yourself, what line has every point with an x value of 2? So every point that I just graphed has an x value of 2. This point is at 2, 9. This point right here is at 2, 6. This point right here is at 2, 1. So every point on that line has an x value of 2. That is what you want. As far as shading goes, if you test 0, it comes out to be false, so you would shade away from 0. But you can also just think of the x-axis as a number line. If it says x is greater than 2, that means you need to shade all values larger than the x value of 2, which is the right side of that pink line. And the last line that we are graphing is y is greater than or equal to 0. That tells us as an equation we would be graphing at y equals 0, which is a horizontal line that follows right along the x-axis. If y is greater than 0, you would want all y values greater than 0, or if you test a point, you would be shading above this line. Combine all of your shaded regions above the blue line, which would be here, to the right of the pink line, which is over here, and above the orange line, which is obviously here, would give you this as your shaded region. This is an unbounded region, meaning it goes on forever. So this graph extends, you could shade up this way forever, you could shade this way forever. It extends on past what you see on this graph. So there are only two vertices that we can actually mark. There's a vertex located at this point, which is 8, 0. And there's a vertex located at this point, which is at 2, 3. If I list those as my vertices, we have 2, 3, and we have 8, 0. We need to test these values in our objective function. Don't forget that your objective function is always the equation that you have. In this case, it's x plus 3y. Don't make up objective functions. They're going to be given to you for these problems, and then in word problems, you obviously write them. But don't make them up. Make sure you use the correct objective function. X plus 3y is what we're using for this problem. I'm going to evaluate both of these points in this objective function. When I evaluate 2, 3, that gives me 2 plus 3 times 3. This is equal to 2 plus 9, or 11. The next ordered pair is at 8, 0. That would be 8 plus 3 times 0. This is equal to 8 plus 0, or 8. So here's where these problems differ. Your answer is not determined yet. Your answer is going to be one of those. But when you have an unbounded region, you have either a maximum or a minimum. You do not have both. You can't have both because it's unbounded. So you have one or the other. You can't say, all right, well, this looks like it's heading up forever, so this must be the lowest point, therefore it's a minimum. Done. That does not work. The minimum or maximum is determined by the objective function. That objective function could be negative x minus 3y, and you end up with totally different answers for this problem. So that objective function is telling you what your min or max is. On the first page, we highlighted this, but I'm going to write it down here as well. You have a min or a max. When I say min, I'm talking about minimum. You do not have both. So your answer is going to be one of these two values, but you have to test another point, at least one other point, in order to determine which one it is. So at this point, we don't know. Is 11 going to be our maximum, or is 8 going to be our minimum? We have no way of knowing at this point. So what we do is we pick at least one test point. I usually do 2, just so I can be sure that I picked the right answer. And for a test point, you pick any point in the shaded region. I like to pick points kind of close, like in line to the vertices, but obviously not right next to them. So I'm going to pick the point I just labeled, which is at 3, 9. And I'm going to test that in my objective function. So if I test 3, 9 into my objective function, I have 3 plus 3 times 9, which is 3 plus 27, which is 30. I'm going to do one other point. I'm going to pick this point here. And that point is at 10, 1. At 10, 1, the objective function would be evaluated at 10 plus 3 times 1, or 10 plus 3. And this is equal to 13. So here's where you have to pay attention to what you're doing. Your answer is either going to be 11 or 8. Based on the two numbers that I just highlighted, 11 or 8, and our test points, which is 30 and 13, is 11 the highest number you have, or is 8 the lowest number you have? And in this case, 8 is the lowest number we have. So 8 would be our minimum. There will never be a value that is lower than 8. That vertice is your answer. It's going to be labeled a minimum. You have to test values to determine which direction it's going in. Suppose my answers came out to be negative 30 and negative 13 instead of positive 30 and positive 13. In that case, this would then be the maximum because that's your highest value of all the values on the graph. Of course, that is not what just happened. What happened was we determined 8 is going to be the smallest number. Every other number we tested is larger than 8, so that means it has to be your minimum. When I write this down, I would indicate that there is no max value. There's a minimum value of the objective function at 8. It occurs at 8, 0. That would be your solution. Please take a moment and complete this practice problem by yourself.